Good evening, students. How are you all? I'm Kanika ma'am, your mathematics teacher. So, in the previous series, we had completed the first chapter, that is real numbers. Now, today we are going to start with a new chapter, that is polynomials. So, welcome to the first session of polynomials here. Polynomials we've done in grade 9 also, and in grade 8 there was one small introduction in the form of algebraic expressions. In that particular chapter, there was just a few polynomials where we dealt with. So polynomials, since I just told you, we've done earlier also. So let's start with the introduction here. An algebraic expression is an expression made up of variables and constants along with mathematical operators. So right now I'm talking about the algebraic expressions. They are expressions which are made up of variables and constants along with the mathematical operators. That means we have plus, minus, division sign in between. Now, a term is a product of variables and constants. A term can be an algebraic expression in itself. Now, this means that, for example, if we have an algebraic expression 5x square y plus 4xy plus 2x plus 3, in this algebraic expression, the terms are 5x square y, 4xy, 2x and 3. Now, these terms, they are product of variables and constants. And a term can be algebraic expression itself. That means I can also consider this as an algebraic expression. Also, children, please notice we have 5x square y plus 4xy, 2x plus 3. So, they are all positives here. Now, what if I write here 5x square y minus 4xy minus 2x plus 3. So, in this case, the terms would be 5x square y minus 4xy minus 2x and 3. So, please notice we are going to consider the signs also. So, if it's positive, you will write positive, or even if you don't write anything, that's okay. And if it's negative, it's minus sign, you have to mention that. Now, an algebraic expression can have any number of terms. The coefficients in each term can be any real number. There can be any number of variables in an algebraic expression. The exponents on the variables, however, must be rational numbers. So, if we have an algebraic expression, it can have any number of terms. The coefficients of each term can be any real number. By coefficient mean that if I have x square y as the variable thing, this is called the coefficient. So, this coefficient can be any real number. In this case, this xy has coefficient minus 4. So, the coefficients can be any real numbers. Now, there can be any number of variables in the algebraic expression. So, like in the previous example, I gave you just two variables, x and y, but then you can put any number of variables here. And the exponents on the variables must be rational numbers. So, here the exponents, like we have exponent 2 here, we have 1 here, 1 here and 1 here. So, they must be rational numbers. Now, coming to the new concept which we'll be dealing with today, that's polynomials. So, polynomials, they are also algebraic expressions, but there's one small difference here. An algebraic expression can have exponents as rational numbers. However, a polynomial is an algebraic expression in which the exponent on any variable is a whole number, or we may say non-negative integers. Now, this means, as I just told you, that algebraic expression can have the exponents, the variables will have the exponents as any rational number. But in polynomials specifically, the variables must be whole numbers, only whole numbers. Whole numbers, right, means starting from 0, 1, 2, 3, 4 and so on. So, the powers here of the variables, they must be whole numbers, then only we are going to call it polynomials. If they are rational numbers, we'll call it algebraic expression, and polynomials, we must have the powers as whole numbers. Like we have 5x cubed plus 3x plus 1. It is an example of a polynomial. It is an algebraic expression as well. So, it's an algebraic expression, but further we can say that it's a polynomial since the variables, they have powers as whole numbers. We can see we have 3 here and then 1 here. Now, till now we've learned algebraic expression, we have learned polynomials also, and we have learned the difference between these two. Now, let's talk about just see here, we have 2x plus 3 root x. It's an algebraic expression, but not a polynomial. As we can see that x has a square root on it. It's 3 root x. 3 root x means x has the exponent 1 by 2. X has the exponent 1 by 2. The variable has exponent 1 by 2. It's not a whole number. So we can say 2x plus 3 root x. It's an algebraic expression but not a polynomial. Now the standard form of the polynomial is given by an x raised n plus an minus 1 x raised n minus 1 and so on up till a1 x raised 1 plus a naught x naught, where n is a non-negative integer and a naught, a1 up to an are constants. They are all real numbers. Now children, in standard form for a polynomial, we usually write the highest power as the first one, then the power below that and so on. So the powers of the variables, they must be in decreasing order. So like if I have a third degree polynomial, I'm going to write 3 x cube term, then square term, then x term, and then the constant term. Now degree of a polynomial, I just said that if it's a third degree polynomial, what does that mean? For a polynomial in one variable, the highest exponent on the variable in a polynomial is the degree of the polynomial. This means that if I have a polynomial x square plus 2x plus 3, I can see this has power 2, this has power 1, and this doesn't have a variable. So we'll talk about this also afterwards. So this has, we can see that the highest power here is 2. So the highest power we consider as the degree of the polynomial. So this polynomial has degree 2. Now let's take x square plus x cube plus y. This has power 2, this is power 3, this is power 1. So we can say that the degree of this polynomial is 3. The degree of the polynomial is 3 since this is the highest degree. Now we can classify the polynomials based on number of terms and the degree of polynomial. So first of all, we are going to deal with the classification of the polynomials on the basis of number of the terms they have. So if a polynomial has just one term, like we have minus 2x, 6x squared, 9xy, these are all polynomials with just one term. So they are called monomials. Monomials are the polynomials having only one term. Now comes binomial. A polynomial with two terms. For example, if I have polynomial 4x squared plus x, if I have 5x plus 4. So these are all polynomials with two terms. They are called binomials. Now comes trinomial. Tri, as the word says, tri means 3. So a polynomial with 3 terms, polynomials with 3 terms, they're called trinomials. For example, I have x squared plus 3x plus 4. So these are all, this is called a trinomial. Now children, please notice the terms here should be all unlike. If I write x squared plus 3x squared plus 4 and I say that these are 3 terms, so it's a trinomial, then I'm wrong. The reason for this is these two are like terms. Since they're like terms, we can combine them. So we can write this as 4x squared plus 4. So it's actually a binomial. It's not a trinomial. Same is the case with a binomial. If I have 4x squared plus x, let's say if I make it 4x plus x. So I'm not writing here x squared, I'm writing x. So these two terms are like terms. We can combine and we can write them as 5x. So this becomes a monomial. So actually this is not a binomial, it's a monomial. So make sure when you are categorizing the polynomials as monomial, binomial and trinomial. In case of binomial, make sure that the terms, they are unlike terms, and the same is the case of trinomial. They should all be unlike terms. We should not have any like terms so that we can combine and bring it down to a binomial. So make sure that the terms here are unlike. So one term, it's a monomial. 2 terms, binomial. 3 terms, trinomial. Now let us discuss the types of polynomials based on the degree. So degree, as I just said, I'm repeating myself. Degree means the highest power of the variable. Now let's talk about constant polynomial. A polynomial whose degree is 0 is called a constant polynomial. The standard form is ax raised 0. For example, we have 25, 9, root 5, etc. So these numbers actually which we have in the end, I'll just show you again. Like if I have here 4, this, if I just independently take this number 4, it's a constant polynomial. So why it's a constant polynomial and why is the degree 0? Like as I just said 4, I'm just taking this 4, that's a number for me, and I'm saying that it's a constant polynomial, its degree is 0. Why is the degree 0? I can write 4 as 4 into 1, and I know that any number raised to the power 0 is 1. So x raised to the power 0 is 1. Any number raised to the power 0 is 1. It's an axiom. We've done this in grade 7 and grade 8 also. So I'm going to replace this 1 by x raised to the power 0. So 4 I can write as 4x raised to the power 0. So now I can see that the degree of this polynomial is 0. It's a constant polynomial because it remains the same throughout. Even if you put any particular value of x, the value of the polynomial will still remain the same. Even if you put here 100, if you put 25, any number raised to the power 0 is 1. So the value will be fixed here. It will be the same. It will be constant. That's why we call it constant polynomial. So children, I'm repeating myself. A polynomial whose degree is 0 is called a constant polynomial. So if I just write any number, I've written 4 here. If I write root 5, this can be written as root 5x raised to the power 0. So it's again a constant polynomial with degree 0. Now, however, 0 is also constant polynomial, but we are not considering it as constant polynomial. Rather, we consider it as a special polynomial named as 0 polynomial. So 0 is constant, but still we are going to give a special name to it. It's not a constant polynomial. It is called 0 polynomial. Now for 0 polynomial, I can write 0 as 0 into x. I can write 0x square. I can write 0x raised to the power 100. I can write 0x raised to the power 50. Like this, I can just give x raised to the power anything. So what is the degree of 0 polynomial? The degree of 0 polynomial is not defined because I can write it as 0 multiplied by x raised to the power any whole number I can write. So here we have 0 polynomial. It's constant, but still we have given it a special name, that is 0 polynomial, and the degree of 0 polynomial is not defined. Now comes linear polynomial. Now you are already aware of this term linear. We have already studied linear equations in grade 9. Also we've done linear polynomial also. A polynomial whose degree is 1 is called linear polynomial. Like I have x plus 5. It's a linear polynomial. As I can see that the degree here is 1. This has power 1 and it is the highest power. So the degree is 1. So the standard form for a linear polynomial is ax plus b, where a and b are real numbers and a is non-zero. A is non-zero because if a becomes 0, then x term will disappear and we will be just left with b. We will be just left with b and it will actually become a constant polynomial, not a linear polynomial. So we have example for the linear polynomial as 2x plus 1. Now we have quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. Degree 2, that means the highest power here is 2. Let's say if I write x square plus x plus 1. This is the highest power, that's 2. It's called a quadratic polynomial. The degree is 2. It's called quadratic polynomial. The standard form for the quadratic polynomial is given by ax square plus bx plus c, where a, b, c, they are real numbers and a is non-zero. Again, it's the same thing. If a becomes 0, this term will disappear. Because 0 multiplied by anything will be 0. So we'll remove this term and we'll be just left with bx plus c. That will become a linear polynomial. That is why the coefficient here of x square we are specifically taking as non-zero. So a must be non-zero. For example, we have a quadratic polynomial here. 3x square plus 8x plus 5. It's an example for a quadratic polynomial. Now comes cubic polynomial. A polynomial of degree 3 is called cubic polynomial, and the standard form for the cubic polynomial is given by ax cube plus bx square plus cx plus d. So please notice children, we are starting with the highest power 3 and the powers are in decreasing order. We have 3, 2, 1 and 0. Here this has the variable x. You can just say that d has variable x and the power here is 0. dx, we can write this as dx raised to the power 0. So usually we don't write. So the powers are in decreasing order. A, B, C, D, they're all real numbers and A is non-zero. A is not equal to 0 because we have to retain this x cube term since we are talking about cubic polynomial. Now example for a cubic polynomial is also given to you here. We have 2x cube plus 5x square plus 9x plus 15. It's a cubic polynomial. Now we've already discussed zeros of the polynomial in grade 9 also. So I'll just quickly revise the same. A zero of the polynomial px is the value of x for which the value of px is 0. This means if you take a polynomial, let's say, I'll give you an example. Let's say if I have x minus 2. That particular value of x, if you replace x by any particular value such that this entire polynomial, its value becomes 0, then we say that it's 0 of the polynomial. For example, if I put x is equal to, I'm going to replace this x by 2. I'm going to get 2 minus 2, that is 0. So x is equal to 2 is making this polynomial 0. So we can say that 2 is 0 of the polynomial. So I'm just reading this again. A zero of the polynomial px is the value of x for which the value of px is 0. That means the value of the polynomial becomes 0. If k is 0 of px, then p of k is equal to 0. So if we know that 2 is 0 of this polynomial x minus 2, then p of 2 will become 0. For example, we have a polynomial px, that is x square minus 3x plus 2. And if we put x is equal to 1 here, so I'm going to replace x by 1. So I'm going to get p of 1 as 1 square minus 3 into 1 plus 2. So 1 square can be written as 1, minus 3 into 1 will become minus 3, and plus 2 we've copied as it is. Now we can see 1 minus 3 plus 2 will give us 0. So we are getting p of 1 is equal to 0. That means x is equal to 1 is making this polynomial 0. It's making this polynomial 0, so we can conclude that 1 is 0 of the polynomial. Now since px is equal to 0 at x equal to 1, we can say that 1 is 0 of the given polynomial. Now, geometric meaning of zeros of the polynomial. What does zeros of the polynomial means geometrically? Geometrically, zeros of a polynomial are the points where its graph cuts the x-axis. So when a polynomial is given to you and you have to draw the graph of the same, the points at which the graph cuts x-axis, those are zeros of the polynomial. For example, in this first case, in the first graph, we can say it's a straight line and it is cutting x-axis at minus 2. Here it has 1, 0, that is minus 2, 1, 0. It is cutting the x-axis at one point, it has 1, 0. These are the zeros for this polynomial. So this is graph of a different polynomial. As we can see that it is cutting the x-axis at minus 2 and 4. So these are zeros of the polynomial. Now we have another graph. It is cutting x-axis at minus 1. We have 2 here and then we have 3 here. So here these are zeros of the polynomial. So in the first case, we can say that there is only 1, 0 because it is cutting the graph at a single, cutting x-axis at a single point. This is cutting x-axis at 2 points. So it has 2 zeros. It is cutting x-axis at 3 points. So it has 3 zeros. Now, number of zeros. Now, how many zeros do we have for a polynomial? Like as I said, that for this polynomial, it is cutting the graph at 1 point. So it has 1, 0. Cutting the graph at 2 points. It has 2 zeros. So how we are going to figure out that? In general, polynomial of degree n has at most n zeros. Has at most, maximum n zeros. A linear polynomial has 1, 0. Linear polynomial has degree 1. So it has 1, 0. Quadratic polynomial has at most 2 zeros. Quadratic polynomial has degree 2. It has at most 2 zeros. A cubic polynomial has at most 3 zeros. Cubic polynomial has degree 3, 3 zeros. So finally, we can conclude that if I have for a polynomial as degree n, it has at most n zeros. So a linear polynomial has degree 1. So it will have 1, 0. A quadratic polynomial has degree 2. It has at most 2 zeros. A cubic polynomial has degree 3. It has at most 3 zeros. What if for a particular polynomial I have degree 5, I'll have at most 5 zeros. Now this is the question for NCERT, the first exercise of polynomials. The graphs of y is equal to px are given in figure 2.10 below. For some polynomials px, find the number of zeros of px in each case. Now, as I just told you earlier, for a polynomial, if you take a graph and the points at which the graph cuts x-axis, those are zeros of the polynomial. Here we just have to find at how many points the graph is cutting x-axis, since we have to find the number of zeros of px. Now here for this graph, we can see that this particular graph is not cutting x-axis at all. So it has no zeros at all. We don't have any zero for this polynomial. Now in the second one, we can see that the graph is cutting x-axis at a single point. So it has 1, 0. Now here the graph is cutting at 1, 2 and 3 at 3 points. So we can say it has 3 zeros. This graph is cutting x-axis at 1 and 2 points. So it has 2 zeros. This graph is cutting x-axis at 1, 2, 3, 4 at 4 points. So it has 4 zeros. Now the last one, we have 1, 2, 3. So this graph is cutting x-axis at 3 points. So it has 3 zeros. Now the relationship between the zeros and the coefficients of the polynomials. Now first we have a linear polynomial. We've just studied for a linear polynomial, the standard form is ax plus b. That's the standard form. Now the value of x for which the polynomial reduces to 0 is minus b upon a. So if I take this ax plus b, that's a linear polynomial, and I equate it to 0, and then I try to find the value of x, I'm going to get x as minus b upon a. So minus b upon a will make, if I put in place of x, this is going to make the polynomial 0. So that's the relationship between the constant and the coefficient of the polynomials. This is the case of linear polynomial. So x, that's 0 of the polynomial, is minus b, that's minus of the constant term upon the coefficient of x term. Now comes the next one, which is very, very important. If alpha and beta are zeros of the quadratic polynomial. Please notice this quadratic polynomial, the relationship between zeros and coefficients is very important, and you will get a lot of questions based on the same. So for a quadratic polynomial, the standard form is ax square plus bx plus c, and a is non-zero. Then we have already taken alpha, beta as zeros of this quadratic polynomial. As discussed earlier, a quadratic polynomial has degree 2, so it has 2 zeros. We have taken 2 zeros as alpha and beta. Now, if I take alpha and beta and I add them, so I'm talking about the sum of zeros here, then this will be same as minus b upon a. That means minus the coefficient of x upon the coefficient of x square. In the same way, if I'm taking alpha and beta and I'm going to multiply them, then this product will be same as c upon a. C upon a means constant term upon the coefficient of x square. Children, I am repeating this entire thing again. If we have a quadratic polynomial we already know has degree 2. It has degree 2, so it has 2 zeros. Let us take 2 zeros as alpha and beta, and the quadratic polynomial we have taken in the standard form as ax square plus bx plus c. Now, if we take alpha and beta as 2 zeros and we add them, so sum of the zeros will be same as minus b upon a. That means minus the coefficient of x upon the coefficient of x square. In the same way, if we take alpha and beta, the zeros of the polynomial, and we multiply them, the product will be same as c upon a. C, that is the constant term, upon a, that's the coefficient of x square. Now let us use this in the next question. The next question I am taking from NCERT, that's the second exercise. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So we actually have to verify these two relations which we have just discussed. So we have a quadratic polynomial. We have to, first step is we have to find the zeros of this polynomial. Now the zeros of the polynomial, how to find that? This we've learned in grade 9 also. We are going to solve it using split the middle term method. So here, the first step is, even before you use the split the middle term method, you have to first of all make sure that this polynomial is written in standard form. So we can see it's written in standard form. We have x square term, we have x term, and then we have the constant term. Now we have to somehow find the zeros of the polynomial using split the middle term method. That means we are looking for two numbers whose product is minus 8 into 1, the coefficient here also. Usually children miss out the coefficient here. Usually it's 1 only, but then even if you get a number other than 1, you have to multiply it. So actually we are looking for two numbers whose product is minus 8 into the coefficient here, that's 1. So that's minus 8 only. And the sum should be minus 2. That's the coefficient of x term. So we are looking for two numbers whose product is minus 8 into 1, that's minus 8, and the sum minus 2. So if we have minus 4 and 2, minus 4 and 2 will give us the product minus 8, and the sum we are going to get minus 2. Now since we've got the numbers, we are going to split this middle term. So we have here x square minus 2x minus 8 equal to 0. Now I'm going to write this minus 2x as minus 4x plus 2x minus 8 is equal to 0. We have to somehow find the value of x which is making this 0, this entire polynomial 0. Now we are going to take these two terms and these two terms. We'll take out common from here. We know x is common from these two terms. We'll be left with x minus 4. From these two terms, we can take 2 common. We'll be left with x minus 4. That's equal to 0. Now, please observe here, x minus 4 and x minus 4, they're common. So, I've taken x minus 4 common, and I'm now left with x plus 2 is equal to 0. Now, we have, now the product of two numbers is 0 only when either one of the numbers is 0 or both of them are 0. So, in this case, we can say x minus 4 is equal to 0 or x plus 2 is equal to 0. So, from here we can conclude x is equal to 4 or x is equal to minus 2. So, please notice here x is equal to 4 and x equal to minus 2. These are two zeros of the given quadratic polynomials. Now, we have got the zeros of the polynomial. I hope you've all understood till here. Now, we are going to verify the relationship between the zeros and the coefficients. The relationship means that I'm talking about this alpha plus beta equal to minus b by a. We have to check whether alpha plus beta, that means the sum of the zeros, is coming out to be minus b by a. So let's see. We know that the zeros are 4 and minus 2. So I have to check alpha plus beta is equal to minus b by a. Now alpha here is 4 and beta is minus 2. We have two zeros, alpha 4, beta minus 2. That is what we have solved for in the previous step. So alpha plus beta would be 4 plus minus 2, that is 2. So I have got this alpha plus beta as 2. Now let us see what is minus b by a. Minus b by a is minus, if I put this in the standard form, this is ax square plus bx plus c. So this is already in standard form. I'm comparing this with ax square plus bx plus c so that I can figure out the values of a, b and c. So if I compare these two, I observe here that a is 1, b is minus 2 and c is minus 8. A is 1, b is minus 2 and c is minus 8. Now we have to solve for minus b upon a. Minus b upon a. That's minus 2 upon a. A here is 1. So I'm going to write here 1. So finally I'm getting 2 here. So please notice alpha plus beta is 2 and minus b upon a is also 2. So we can say alpha plus beta is equal to minus b upon a. So now we have verified the first relationship between the zeros and the coefficients. Now let us discuss the second relationship, that is alpha beta is equal to c upon a. Alpha beta equal to c upon a. The product of the zeros should be same as c upon a. Now we have the zeros 4 and minus 2. Let's take alpha beta, the product of zeros. We'll get 4 into minus 2, that is minus 8. Now this should be equal to c upon a. So let's check what is c upon a. C is minus 8 and a is 1. So c is minus 8 and a is 1. So this is also giving me minus 8. So alpha beta is same as c upon a. Alpha beta is same as c upon a. Hence, we have verified both the relationship between the zeros and the coefficients of the polynomial. Okay, so I'm discussing this all over again. I'm explaining this right from the beginning. Please be very attentive. In this question, we have to first find the zeros of the quadratic polynomial, and we have to verify the relationship between the zeros and the coefficients. That means we are going to first find the zeros, and then we are going to check whether the sum of the zeros is coming out to be minus b by a, and product of the zeros is coming out to be c upon a. Now we have the polynomial x square minus 2x minus 8. We are going to solve for the zeros of the polynomial using split the middle term method. Now we want two numbers whose product is minus 8 into 1. Minus 8 into the coefficient here, that's minus 8. And the sum, we want minus 2. That's the coefficient of x. So if I take minus 4 and 2, I'm going to get the product minus 8, and I'm going to get the sum as minus 2. Now, in the next step, since we've got these two terms, we are going to write this 2x as minus 4x plus 2x. So, x square I've written as it is, minus 2x I've written as minus 4x plus 2x, and minus 8 I've copied as it is. Now, we'll take first two terms, and we are going to take x common from here. So, we'll be left with x minus 4. And in the next two terms, we've taken 2 common. So, we are now left with x minus 4. Now, please observe here, x minus 4 and x minus 4, they are common. They're the same here. So, we'll take x minus 4 outside, and we'll be left with x plus 2. Now, either x minus 4 is 0 or x plus 2 equal to 0. Because the product of the numbers, two numbers, if we are getting as 0, either both of them are 0 or any one of them is 0. So, from here, we can say either x is 4 or x is negative 2. Now, x4 and x negative 2, these are two zeros of the polynomial. Now, these two zeros of the polynomial, we need to check whether when they add, they are giving us minus b by a, and when we multiply them, they're giving us c by a. So, we are going to first verify the first relationship. Sum of the zeros is same as minus b by a. So, sum of the zeros means alpha we are taking 4 and beta we are taking as minus 2. 4 and minus 2 is we have solved for in the previous step as the zeros of the polynomial. So, we have 4 plus minus 2, that is 2. Now, we have to check what is the value of minus b by a. So, minus b upon a, we have taken this expression, the polynomial which is given to us. We have compared this with the standard form for a quadratic polynomial, that is ax square plus bx plus c. And from here, we can observe that a is 1, b is minus 2, and c is minus 8. Now, we are going to take the values of b and a, and we are going to put it here. We want minus b upon a. So, minus b upon a is minus 2 upon 1, that is 2. So, we are getting the sum of the zeros and the coefficient minus b upon a as 2. So, from here, we can conclude that alpha plus beta is same as minus b upon a. Now comes the second relationship, which is related to the product of the zeros. The product of the zeros is same as c upon a. So, we have alpha, beta here. Alpha is 4, beta is negative 2. When we multiply them, we are going to get minus 8. And then we have c upon a. C upon a is minus 8 upon 1. Please notice, c is minus 8 here and a is 1. So, we have just picked up these values and we have put it here. So, we are getting minus 8. So, both of them, they are equivalent to minus 8. So, alpha, beta is same as c upon a. And then you can write hence verified. I hope you've all understood this. We'll do one more question of this type. So, in the second part of this exercise here, it's given 4s square minus 4s plus 1. This is the given polynomial. We have to do the same thing. We have to first find the zeros of the polynomial, and then we have to verify the relationship between zeros and the coefficients. So, the first step here is I'm going to take ax square plus bx plus c. I'm going to compare this with the standard form for a quadratic polynomial, and then we are going to get a as 4, b minus 4, c 1. We've got this. Okay. Now, give me 1 minute. After this, we've got a, b, c. We've got now the next step is I'm going to solve for the zeros of the polynomial. So we have 4s square minus 4s plus 1. We want two numbers whose product is 1 into 4. 1 into 4, that is 4. Positive 4 we want. And the sum we want as minus 4. So if I take minus 2 and minus 2, that is going to give me the product positive 4 and will give me the sum minus 4. So now I'm going to split this middle term in the next step. So I will write 4s square. This I've copied as it is. This minus 4s can be written as minus 2s plus 1. Now let's take common from here. We are going to take 2s common and we'll be left with 2s minus 1. From here, nothing is common, but please make sure that you make this next bracket the same. If you don't make it same, you will get stuck. You will not be able to proceed further. So what do you have to do? Take minus common and then you will be left with 2s minus 1. So we have 2s minus 1. We have 2s minus 1 here. We can take this 2s minus 1 common and then we'll be left with 2s minus 1 here. Now we have 2s minus 1 and now from here we can say either s is 1 by 2 or s is 1 by 2. Please notice, even if you are getting the same zeros, you are supposed to write them twice. So even if you are getting 1 and 1 again, do write it twice. We are going to consider it as two different zeros. So it's a quadratic polynomial with two zeros, 1 by 2 and 1 by 2. The next step is we are going to verify the relationship between the zeros and the coefficients. That means we want to check whether alpha plus beta is same as minus b by a. Now alpha plus beta here is 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 will give us 1. We are getting 1 here. And minus b by a, minus b is minus, b is minus 4 and a is 4. So minus b by a would be minus 4 upon a, that is 4. So this is actually 4 upon 4, that is 1. So finally we are getting alpha plus beta is 1 and minus b by a also we are getting as 1. So we have now verified the first relationship between the zeros and the coefficients. Now let us discuss the quadratic thing. Let us discuss the product of the zeros. We have alpha, beta, that's the product of zeros here. And then we have, I think this is what it is. Doesn't matter. Now we have s, we've got as 1 by 2 and 1 by 2. That we already know. Now we are going to verify the relationship between the product of the zeros and the coefficients here. So alpha beta is equal to c by a. This we need to check. Now alpha beta is 1 by 2 into 1 by 2. That is 1 by 4. C upon a. C is 1 and a is 4. So we are going to put c as 1 and a as 4. This is also 1 by 4. Finally, we have got alpha beta is equal to c upon a. So we have verified this relation also. So finally, we have verified the relationship between the zeros alpha beta. So in this case, we were having 1 by 2 and the coefficients and coefficients here. Now, for this entire exercise, you have to do the verification part, solving for the zeros and the verification part for all the parts. But I've done for 2 of these. Rest you can do yourself. The other parts, I'm going to discuss how to calculate the zeros. Once you get the zeros, you can do the verification part also. So here we have 6x square minus 3 minus 7x. We have to solve for the zeros of this polynomial. Children, please notice, right in the beginning I told you, you have to first check whether the polynomial is in standard form. You should first have x square term, then x term, and then the constant term. This polynomial is not in standard form. So the first step is, I'm going to write this as 6x square minus 7x minus 3. So I'm going to rearrange the terms and I'm going to write this in the standard form. Now I will proceed. Now I'll see what to do. We have to solve for the zeros of this polynomial. So we want two numbers whose product is minus 3 into 6. The constant term here multiplied by the coefficient of x square. So we have minus 3 into 6, that is minus 18. And we want the sum as minus 7. Minus 7, that's the coefficient of x. Now, if I take 9 and 2, that is going to give me the product 18. I want the product as minus 18. So I need to have any one of them negative to get the product minus 18. Now how to figure out that? I also want the sum as minus 7. So if I take minus 9 and 2, I'm going to get the product minus 18 and I'm going to get the sum as minus 7. So this will satisfy the condition and now we can proceed. So we are going to split this 7x minus 7x. So we have 6x square minus 7x minus 3. We are going to write this as 6x square minus 9x plus 2x minus 3. So I've written this minus 7x as minus 9x plus 2x. Now we are going to take common from here. We can see here 3x is common and then we'll be left with 2x minus 3. Here also we'll take common. So nothing is common. So we will actually take 1 common. So we have 2x minus 3. Children, please make sure that these two brackets should be the same. If they are not coming out to be the same, then you will get stuck. So you have to somehow make them same. And if they, in any case, are not coming out to be same, that means you've made some mistake. Now we have 2x minus 3, 2x minus 3 here. You're going to take this common and then we have 3x plus 1. Now from here we can see either x is 3 by 2 or x is minus 1 by 3. So these are two zeros. We have 3 by 2 and minus 1 by 3. Understood this, children? Yes. So the only important step here is to figure out the numbers whose product you get and the sum you get. Once you get the numbers, it is very easy to solve. You just have to take common. You've done this in grade 8 also in factorization chapter. Now comes the next one. Let's discuss this one. T square minus 15. We have t square minus 15. Please notice here we don't have any middle term. There's no t term here. So how to solve for the zeros? So we have t square minus 15. We don't need any split the middle term in this case. We have to somehow find the value of t so that this polynomial is 0. You can equate it to 0. Now let's see. I'm going to take this 15 on the other side. We have t square is equal to 15. We need to solve for that value of t which is going to make this polynomial 0. We are solving for the value of t. We are not solving for the value of t square. So since I want the value of t, I'm going to take square roots on both the sides. So if I take the square t here, I'm going to get here square root of 15. This is a very, very common mistake which children make. They only consider the positive thing. Please notice whenever you are taking the square root, consider positive or negative. Because positive root 15 will give you t square as 15. Negative root 15 will also give you t square as 15. So here we have t as positive root 15 or negative root 15. So these are two zeros of the given polynomial. Understood this? Now how to verify? How to verify the relationship between the zeros and the coefficients? Since you don't have your t term, what we are going to do, we'll write this t square minus 15 as t square plus 0 into t minus 15. T square plus 0 into t minus 15. I need to get that t term so that I can figure out the coefficient of t term here. Now if I compare this with ax square plus bx plus c, I can observe that a is 1, b is 0 and c is minus 15. Now since you've got the values of a, b and c here, now you can very easily verify the relationship between the zeros and the coefficients. We have to check whether alpha plus beta is coming out to be minus b by a. Now this is alpha and this is beta. These are two zeros of the polynomial. So if we have plus root 15 minus root 15, we add them, we'll get 0. So alpha plus beta here is plus root 15 minus root 15. This is going to give us 0. Now if I take minus b by a is 0 upon 1. It is 0 upon 1 minus 0 upon 1. This we are going to get 0 upon 1, that is 0. So in any case, we are getting here 0. Alpha plus beta is equal to minus b by a, since both of them are coming out to be 0. Now comes the product of zeros. We have to check whether alpha beta is same as c upon a. Alpha beta here is root 15 into minus root 15, that is actually minus 15. It's plus into minus will give us minus. Root 15 into root 15 will give us 15. Then we have C upon A. C here is minus 15, A is 1. So we will write here minus 15 upon 1, that is minus 15. Finally, here we have got alpha beta as minus 15 and C upon A as minus 15. So we can say alpha beta is same as C upon A. So we have verified the relationship between the zeros of this polynomial and the coefficients. I hope children the concept is clear to you, and please practice before you come for the next class. We'll discuss a few more questions based on the same concept, and also in the next class, in tomorrow's class, we are going to learn how to form a polynomial when the zeros are given to us or when we know the sum of the zeros and the product of the zeros. So we are going to discuss this in detail in the next class, and I request you all to practice before you come for the next class. Please go through NCERT and just whatever doubts you have, please come